Good morning, everyone. Welcome to our webinar, Utility Scale Battery Storage in North Carolina. Thank you for joining us today. I'm David Farmer, Senior Engineering Consultant with Advanced Energy, and I'll be your host and moderator for today's discussion. Today's webinar is part of Advanced Energy's Exploring North Carolina's Clean Energy Transition webinar series, formerly known as Exploring NC Smart Grid. Based on stakeholder input received earlier this year, the term clean energy transition was chosen to be more representative of where North Carolina and the industry is headed. A smart grid will continue to be a key part of the transition, but the consensus was that clean energy transition is broader and more fitting. This is the first of 3 webinars to be hosted this year as part of the program and the 18th since we began the series. Advanced Energy is a nonprofit energy firm founded in 1980 by the North Carolina Utilities Commission. It provides research, testing, training, consulting, and program design. Our members are Duke Energy, North Carolina's electric cooperatives, and Dominion Energy. Since 2017, our team of technical and training staff have collaborated on this webinar series to provide stakeholders with a convenient option to learn how smart grid and the transition to clean energy is changing North Carolina's future. Before we go into our presentations, I'd like to cover a few housekeeping items. Today, we're using the Microsoft Teams webinar platform. First, at any point, if you'd like to interact with us, you can submit your questions or comments by using the Q&A button at the top of your screen. The chat feature has been disabled. We'll respond to as many of your questions as we can at the end of the program during our Q&A session. The webinar is also being recorded and will be available on the NCEnergyTransition.org website. Following today's webinar, we'll send a follow-up email with a link to the recording, and you can review any of our past webinars on this site. Finally, following the webinar, there'll be a participant satisfaction survey. We welcome your feedback, so please take a few minutes to complete the survey and help us improve our future webinars. The purpose of today's webinar is to learn how utility scale battery installations are being applied in the region, understand how the technical and economic challenges are being addressed, and gain a perspective of how utility scale storage will help achieve North Carolina's clean energy goals and enhance grid reliability and affordability for all. Today, we're honored to have 2 guest speakers who have vast experience in energy storage technologies. First, we'll hear from Jason Handley of Duke Energy. Mr. Handley is General Manager of the Distributed Energy Group at Duke Energy. He has over 25 years of experience specializing in smart grid, distributed intelligence, and operations management. In his current role, he leads a team of engineers that deploys, operates, and maintains regulated distributed energy resources and microgrids. Prior to that, he was director of the Emerging Technology Office, where he led a team that identified and developed new technologies impacting the electrical grid and oversaw all the ongoing operational aspects on new technology pilot projects. Jason is past chairman of EPRI's IntelliGrid Program Advisory Committee and served on the board of directors for Smart Grid Interoperability Panel and on the National Institute of Standards Technology Smart Grid Advisory Committee. Currently, he serves on the SAS Utility Advisory Board, the Distributech Advisory Committee, and the Smart Electric Power Alliance Advisory Council. Jason has an electrical engineering degree from Auburn, an MBA from Wake Forest. He's a registered professional engineer and a licensed electrical contractor. Then we'll hear from Erik Hall, who's Director of Energy Services and Technology at North Carolina's Electric Cooperatives. Mr. Hall leads a team focused on distributed energy resources such as microgrids, energy storage, renewables, and demand response devices, and assessing new technologies to maximize the benefits of demand reduction and reliability coordination for North Carolina's electric cooperatives. Erik is the program manager for the development of NCEMC's Distributed Energy Resource Management System and a technical lead on NCEMC's Substation Battery Energy Storage Project. He has a mechanical engineering degree and an MBA from Georgia Tech. Previously, he served as a nuclear submarine officer for 12 years and later worked for NC State as a director of energy management and central utility plant manager, where he oversaw the design, construction commissioning, and initial operation of the 11 megawatt Cates cogeneration facility. We're grateful to be joined by our panelists today. And now it's my privilege to turn the presentation over to Jason Handley of Duke Energy. Jason.
Thank you, David. Thank you very much for agreeing to moderate this session, as well as to Advanced Energy for putting this session on. Obviously, there's a tremendous amount that's going on in North Carolina around the transition to clean energy. And speaking about that, we're going to talk a little bit today about utility scale battery storage. And so let's go ahead and advance. And I really think it's important that sometimes to advance technologies, you need to go take a look at where you've been. And this timeline really provides a great representation of our journey so far. And Duke Energy has a long history of energy storage. And as you can see, it started way back in 1973 with our pumped storage hydro station at Lake Jocassee. And a lot of folks may not think about pumped storage as being, energy storage, but it is one of our best assets when it comes to the ability to store energy to be used at a later time. And between our first battery energy storage research project in North Carolina in 2011 and to our first large-scale commercial battery system at the No Trees Wind Farm in Texas, the path has really been set for Duke to really grow our knowledge base and skill sets around energy storage. And so our education efforts really stepped up in 2015 when we installed our first microgrid at our new research facility in Mount Holly, North Carolina. And then after that, we went forward with a microgrid at McAlpine Substation in 2016, which was kind of our first really grid-tied microgrid to our first external customer, which was Charlotte Fire Station 19. And of course, 2020 was a big year for us in storage at Duke because we started dispatching out of the MISO market in Indiana. And we also brought online North Carolina's biggest battery at the time. In our Asheville Rock Hill plant. And, last year was a very big year for us also. We're finishing up 50 megawatts of storage in Florida. And of course, we have plenty of plans for more storage in all of our jurisdictions as we continue to expand the use of battery energy storage. So one question you may be asking yourself is there really a need for energy storage at a utility level? And we think the answer is absolutely yes. In the future, storage is going to play a significant role both for the utility and for our customers. We look at non-wireless alternatives or NWAs, and we try that. What can we realize with these NWAs as far as where's the energy storage? Can we put energy storage that we're going to be allowed to do that we will not have to put grid investments in, but still these NWAs, these non-wire alternatives, will really add to the benefits for our customers through efficiencies and reliability. Now, energy storage is relatively new from an electrochemical standpoint for the utility. It's a new class of asset for us because we've always had to match generation and load second by second. But with storage, we can actually store energy and use it at optimal times to really allow us to be more open and have the ability to integrate more distributed energy resources onto our grid. And having this capacity will allow us to take these new intermittent resources like solar and wind and really be able to control them and dispatch them in a much easier fashion, which will optimize the overall operations for Duke Energy as well as the grid, which will in turn help our customers. And next, if you're not really familiar with the term microgrid, that's okay. You will be relatively soon. Microgrids, especially when they're coupled with energy storage, will allow utilities like Duke to increase the reliability and resiliency for our systems and for our customers. And so microgrids are going to be a big part of our path for energy storage for our customers' future. And one last point on this slide is that with Duke being a vertically integrated utility, we're truly in a really good position to leverage these new storage resources on the transmission or distribution systems to really maximize the value for all of our customers. Because as with being a vertically integrated utility, having the ability to dispatch over that entire T&D grid provides added values for the entire system, whether that be through ancillary services like frequency regulation, voltage improvements, whatever capacity, whatever it may be. So the next slide that I really want to talk about is really the multiple benefits around energy storage. And so the chart, I think, does a great, the graphic does a great job of doing representation around how energy storage can provide customers with multiple benefits. And so that's where you start, and you kind of go around the chart and you really look at the enablement of increased renewable penetration. I mentioned that earlier, but by being able to manage the swings of intermittent resources, we're actually going to be able to integrate more of these DER clean carbon resources into the grid, which is everyone's goal. We also can't reduce any of the reliability or resiliency for our communities by doing this. So we have to ensure that everything that we do is not only doing the right thing from a climate aspect, from a price aspect, but also from a resiliency and reliability aspect. Because cleaner energy is the goal. We want to be able to store energy from renewable sources and then push that back out, dispatch it when it's needed. This will always provide us with more efficient operations, and the ability to strategically site these projects where they make the most sense on a distribution side or a transmission side will only go to really maximize the value for our customers. And one of the things that I think is another word that you're going to hear a lot is flexibility. And flexibility in this new future grid is going to be truly key for how well we're going to be able to operate and maintain this grid of the future. Flexibility from when we're going to be able to use certain types of resources, when we're going to be able to dispatch those resources. And then for energy storage, what's the best time to charge those resources and with what generating resource? So the graphic to the left really just goes through and looks at the different pieces and parts of energy storage and where the benefits truly lay. And as you can see, there's a variety of different services that energy storage can actually provide. And so it does look like it is one of the most flexible types of assets that the utility can push forward in the future. Next, let's talk a little bit about our program overview as a whole. And so really, I guess the question is, where is Duke Energy planning on going with our storage program? Well, my team is currently operating about 35 megawatts of regulated energy storage today. And we have plans, of course, that will be at 55 megawatts in service or under construction very soon after that. Now, that's not just in North Carolina. Like I said, we have assets in all of our jurisdictions. But we've filed our carbon plan on May 16th with the North Carolina Utilities Commission. And within that plan, one of the things that we're doing is we're showing what we expect to be a significant amount of storage that we required, both in transmission for capacity cases and ancillary service cases, and also distribution level cases, whether it be reliability, resiliency, looking at it from a microgrid standpoint. And we're going to continue to look at all the different types of storage that are out there, because we're going to talk in a later slide about a lot of different technologies. But we do believe, looking at the way the industry is shaping up right now, that lithium ion is going to continue to be the dominant chemistry through probably around 2030. We are looking at different technologies around duration, and other advanced storage technologies. Again, we'll speak to that at the end. But lithium ion seems to be right now at a sweet spot between its abilities around duration and its cost factor. As you get longer term storage needs into the 8 to 12 hours and beyond, lithium ion may or may not look to be the best technology in the future. We believe that there's other technologies that are coming that will help that. But then, as always, it takes multiple voices to understand and respond to new challenges. And really, to that end, we need help to advance the storage program for the benefit of our customers. We need forward-thinking regulatory policies that will help us deploy existing and new storage technologies. And then, of course, we have to pay close attention to issues that really are going to be impacting storage. And a lot of those issues center around interconnection costs and schedules. Sometimes The costs can be prohibitive to some of these projects getting really cost positive, and also the schedules. Sometimes when the types of upgrades that may be needed to bring on certain types of projects may or may not fit the scheduled needs of the project. We also are paying very close attention to supply chain availability. As with anything, as everyone knows, with the pandemic, we have seen lead times for a lot of items, not just advanced technology items like energy storage, but even transformers and switches. The lead times have gone up. We, of course, pay a lot of attention to what's going on in our capital at Washington, D.C. and in Raleigh and our other states, and just see what kind of tax policies may be on the horizon there. Is there an investment tax credit that we may be looking at? And of course, the major initiatives that are going on, like what we just talked about with the carbon plan. The carbon plan, of course, is a major piece of legislation that we are responding to right now. And so as we continue to look at energy storage, I thought it's important to give it just kind of an overview of where we're at with expanding our energy storage across our footprints. And so we have a tremendous amount of projects that are either ongoing or completed, and now we're operating. And on most of those cases, in North Carolina, right now we have multiple projects going on. Two of those are R&D projects, as we talked about, the Mount Holly R&D Center and then the McAlpine Microgrid, around 19 megawatts. And then the use cases really are around resiliency, T&D deferral, and bulk system services. We, of course, are always looking for how are we going to integrate more resources, and that's when we move to the Midwest. And as we said, we're now playing into the MISO market. We're bidding some of these batteries into the market for ancillary services needs around frequency regulation or capacity. And then, of course, we just finished up, or we're finishing up now, a large 50 megawatt swath of projects in Florida. By the end of the year, we'll have 50 megawatts online. And so and I know it says 32.7. There's also a transmission project there of about 18 megawatts that's coming online. But again, the use cases are relatively similar, whether they be resiliency, T&D deferral, or frequency regulation. Again, storage is one of those flexible types of resources that can really serve more than just as one tool in the toolbox. It can provide multiple tools. In the last few minutes of my time today, I really wanted to go through just a couple of sites, some things that are really interesting projects for us around energy storage and microgrids. So one of our first forays into this was our Mount Sterling microgrid in the mountains of North Carolina. It's got a 10 kW solar array and a 95 kilowatt hour battery, and it's off the grid. We actually removed 5 miles of AC line that was feeding this communications tower for the U.S. Forest Service. So it is truly a microgrid, and it is truly a DC only based microgrid at this point. It was great news for us because we were able to provide better reliability to the Park Service. It was great news for the Park Service because we were able to give back 5 miles of right of way back to the Park Service. And we've had really good success with this project, and has given us really the forward thinking to look forward new projects and new types like this, where we can increase reliability and do other good things for not only the utility, but for our customers. The next project I want to speak to you about is really the first commercial battery system that we put in North Carolina, and this is the Asheville Rock Hill site. It's an 8.8 megawatt hour battery. It really does support the Western North Carolina Modernization Plan, put in really to look at doing bulk system benefits for going through and looking at peak deferral or peak shifting, if you will. It's been in service now for almost 2 years and providing a great value to our customers in the area. The next project I want to talk to you about is one that we're really excited about and is getting very close to full implementation. The solar and all went online earlier this year, and so 4.4 megawatt hour battery and 2 megawatts of PV in a microgrid. The town of Hot Springs in Western North Carolina was served by about around a 10-mile long line that goes through mountainous territories, and sometimes the town experienced long duration outages. As we got together and ideated with the town, we figured out that the best solution was really to try and find space for a microgrid. And we were able to work closely with a local business to lease the land from them to be able to put in a microgrid. And so we are working right now to finalize this project and really provide that added level of reliability and resiliency for this town of 500 that I think is going to be a great project that really will be something that we can look at and be proud of long term, and then use it as a building block for other microgrids that Duke Energy is going to build in the future. Last couple of slides, I wanted to talk generally about some of the cost curves and lithium ion in general. So as you may or may not know, TRL stands for technology readiness level, and you'll see the advanced battery materials research is at a TRL level 2 to 3. And so really that's around chemistry, and it's around the material science behind how do we get more energy, how do we get more energy density out of some of our lithium ion components. And so there's different types of packaging that can go in. There's different types of material research and cell research. But really where that goes to is we're trying to drive the costs down for energy storage. So it becomes much more affordable for our customers. It does become a resource that is cost competitive with other assets that we want to put out in the field. And so we're really hoping that, and this, of course, this chart that shows these declines in cost curves was from 2019. And I do want to just say that the cost curves have changed a lot since the pandemic. We're not seeing this large drop that we expected. We're actually seeing more of a flattening, and costs for cells themselves, not the overall system, but for cells themselves have actually started to rise again. A lot of that is due to demand in the industry. The EV demand for lithium ion cells is really driving the market. And believe it or not, utilities like Duke are not a big player when you talk about the number of megawatts or megawatt hours that Duke is purchasing or other utilities are purchasing compared to what our large EV manufacturers are doing. So we're continuing to take a really close look at the cost curves and ensuring that whatever we do, we're making the best decision for our customers. And lastly, I just want to spend a few minutes on what else is beyond lithium. And so obviously there's other technologies that have been around forever. Lead acid technology has been around forever from an electrochemical energy storage perspective. And that electrochemical has been great for us, but we also need to think about other types of technologies like flow battery technologies. Flow battery looks to be a really interesting technology for us from being able to get more duration because you can size it based off the number of gallons of analyte and catholyte that you may have to put in. And ultracapacitors or flywheel technology. Flywheels are going to be interesting for us from the need for continuing to have inertia in the grid as we continue to shut down more and more baseload plants that have these huge mechanical turbines that are generating inertia into the grid to help us make it through faults on the system. Things like flywheels, even though they're smaller, are going to be advantageous for us to look at to be able to help bring more inertia back into the system. Thermal storage is going to be huge. And then, of course, other emerging technologies are out there, whether it be liquid air, whether it be kinetic, whether it be molten salt, and compressed air is another type. So we just wanted to throw this out as a baseline before I turned it over to Erik. But I just wanted to say thanks again to Advanced Energy and for everyone on the call today. And we're very excited about where energy storage is going to go for us. And we hope to be able to continue to bring this into a new longer term vision for our customers to meet all their needs. So with that, thank you very much.
Thank you very much, Jason. Before we turn it over to Erik, we do have a quick poll. You should see that poll pop up at a window, and we'll give everybody just a few minutes to answer that poll. Which of the storage technologies Jason just mentioned are you most excited about? And there it is. So just take a minute and respond to the poll. You should see it pop up right in the middle of your screen. If you're on a computer, if you're calling in, you may not see it. But for those of you who can, take just a minute and we'll see how this goes. Okay, so it looks like we still have a few responses coming in, but we'll go ahead now and close the poll. It looks like pretty close, but flow battery seems to be the technology people are most interested in, followed by thermal storage. So thank you everybody for that. And at this point, I would like to turn the presentation over to Erik Hall of North Carolina Electric Cooperatives. Erik?
Thank you, David. And I'd like to echo Jason's appreciation to both Advanced Energy and all the participants in today's call. North Carolina Electric Cooperatives is similarly excited about battery energy storage. And what I'm going to do is leverage some of what Jason's already presented to you. I appreciate what Jason's presented, a little bit of the background for battery energy storage and why. And my presentation is going to focus, on North Carolina Electric Cooperatives and what we are doing in the battery energy storage space, and hopefully provide some thoughtful points for you to consider. I'd like for you not just to receive the information I'm giving, but of course, I'd like this to, expand your understanding, maybe allow you to implement some similar technologies or even technologies beyond what we're implementing. The simple interest in flow batteries, I clicked flow batteries in the question, David. I'll just go ahead and put that out there. And we, North Carolina Electric Cooperatives, that isn't even on our radar yet. So definitely some new technology out there. But then also, I challenge you to challenge the assumptions and the use cases that we are implementing. We really believe in the cooperative ideal and spirit. We are a cooperative, so I'd like to take this presentation, as an opportunity for that. Just a quick overview of what we're going to talk about today. North Carolina Electric Cooperatives, so I'll give you a little background on us. I'll talk about our demand response and distributed energy resource strategy. We'll talk about battery energy storage and the facilities that we have. And then I'll end with a couple of considerations and next steps. So quick slide on North Carolina Electric Cooperatives. So we are the GNT, the Generation Transmission Cooperative for 26 independent distribution cooperatives in North Carolina. We serve about 2.5 million North Carolinians, and that's about 20% of, correction, about a quarter of the population of North Carolina and almost half of the land mass of North Carolina. We're in 93 counties, and we serve most of the rural areas of North Carolina. So we're on the edges, definitely the edges of Duke's and PJM's support or Dominion's support in our state. We have about 1 million meters, and we're 98% residential and small business. One thing I did want to point out, though, is we have our big thing right now is we're trying to build a brighter future for North Carolina and for our cooperatives. And in that, we are, three of our main goals. One is sustainable and affordable energy, and battery energy storage plays a big part in that. Reliability and innovation. You're going to hear the word reliability again and again and again, just as many times as Jason mentioned it during my presentation. And then innovation, battery energy storage is innovation, not just what we're doing, but what we can do in the future. And then local community support. A couple of the use cases we have for battery energy storage actually get right down into the community and how we can support the community. So our demand response and distributed energy resource strategy is really focused on visibility and coordination. So North Carolina Electric Cooperatives is attempting to put as much DER, distributed energy resource, on the grid as possible. We believe that it provides a tremendous amount of reliability and value to our member consumers, our cooperatives. And the only way we can take advantage of that is through visibility and coordination. So one thing you will also see through the presentation is the battery energy storage itself is not enough. You have to have a way to utilize it, and you have to have a way to see it on the grid. And that will permeate through the entire presentation. So when we talk about battery energy storage as a distributed energy resource, one thing that needs to be really considered or understood is that from a stacked services standpoint, it's one of the most capable DER that we can implement. It provides a wide range of services that generate value, create savings, and enhance reliability across the grid. As Jason mentioned, battery energy storage can take on many forms. That could be like a battery, like the battery in your phone, a lithium-ion battery, but it can also be flywheel technology, thermal storage, or some sort of fuel cell. The concept of stacked services, though, ties back to all of these services or most of these types of battery energy systems. So something that we are considering is which of these can we actually take advantage of? When you look specifically to the North Carolina electric cooperatives, we sort of break the use cases and the value streams in half. And not from a numerical standpoint, but sort of like what we're really trying to achieve. On the left side of this, you see the financial benefits, and so market services through energy arbitrage. Basically, we can, in our PGM market, we can charge our batteries when the prices are low, and then we can discharge the batteries when the prices are high, and gain a benefit. Demand response, we can utilize the batteries to reduce our demand during peak periods and reduce our demand costs and our network transmission costs. And then asset deferral. And Jason mentioned this also, transformer upgrades, reconductor operations, and then new lines and substations can all be either put off or in some cases completely avoided through the implementation of battery energy storage. On the other side, we look at what services we can provide. So there are ancillary services, regulation, solar smoothing, voltage support, and power quality. We can take some of the sites we currently have and we can increase their footprint, as in the microgrids, say maybe bring more homes, more circuits into them. And we can also increase the capacity, enabling an increase in the footprint. And then from a reliability standpoint, we can use demand reduction or generation reduction. In this sense, for battery energy storage, that's really just charging the battery. So instead of taking a solar site offline because we have too much generation on a circuit, we can utilize the battery to pull that generation off the line and, in essence, get a generation reduction. Battery energy storage also allows us to perform islanding operations. And when I talk about some of the projects we're working on, you'll understand what I'm talking about there. And then, as I mentioned, community support. And this is an interesting and important aspect of battery energy storage. A lot of our communities, as I mentioned, are rural, and we also have cooperatives that are on the shorelines of North Carolina. The weather there is pretty tough sometimes, and at times, and with some of our projects, we're seeing that we could provide with battery energy storage the ability to power a specific circuit that is either a first responder home base, a communications hub, or possibly a shelter for affected people during a weather event. So lots of services here. Again, the left side is mostly a financial benefit, and the right side is mostly a service to our members or the grander system. So quick summary of the BES facilities, the battery energy storage facilities we currently have. On the left, the graphic there, those are not all battery energy storage facilities. That is all of our demand response or distributed energy resources. However, the light blue colors, the light green dots, and the dark blue dots are sites that have battery energy storage. We currently have 4 microgrids with about 3 megawatt hours of battery energy storage. We have 14 solar plus storage sites with 45 megawatt hours that will all be complete by Q2 2023. And we have 5 that are currently in operation. And then we have a current project in process, which is 10 substation battery energy storage sites. So they're co-located at member cooperative substations for about 80 megawatt hours of capacity. And that's a very exciting project, and it's something that we kicked off earlier this year, and everything should be complete Q3 of this year. So just stepping into these specific projects, these 2, Ocracoke and Butler Farms, are microgrids, and these are what I would call our pilot projects. These were our first microgrids, and just high-level overview for our Ocracoke microgrid. The use case here was we had a long exposed feeder to Ocracoke. It's an island. The way you get to Ocracoke is you either fly or you take a boat. They have high winds and storms. So with the exposed feeder and the high winds and storms, we felt like this was a great location for a microgrid. In addition, the microgrid provides an additional service of, because it's an island, it's on the coast of North Carolina, its peak load periods are during the travel months, and those correspond with costly demand peaks. So this site can also provide demand response. This site includes a 3 megawatt generator, 15 kilowatt solar array, a Tesla 500 kilowatt battery that provides 1 megawatt hour. And then we also have a series of connected devices, smart devices, thermostats, and water heater controllers. So this was our very first microgrid, and it is currently still in operation. Actually, this is going through its first revision of its control system to play better with our distributed energy resource management system, our DERMS. Our second microgrid was at South River, and it's Butler Farms. Interesting aspect about this is we don't own all the components. So our member consumer, Mr. Butler, who owns the farm, it's a commercial pig operation, and he owns the generator and he owns the solar array. So we really just provided the battery and the microgrid controller, and then the tie-in to our distributed energy resource management system. Another interesting aspect is that this site has a renewable generation. So he has a diesel generator, but he also has a swine waste generator for the site. And then I think the most interesting aspect about this, although it's a commercial microgrid, and we utilize it for our services, it serves the community. The way it's tied into the distribution system, we can isolate the microgrid to a series of homes that are on the grid, and in the event of a loss of the transmission power, they can power the homes as well as the farm. Our next set of microgrids are Heron's Nest and Eagle Chase. Little different use case. Heron's Nest is a sustainable community, and it is a developer basically designed a community around the idea of making it sustainable. So each house has a 3 kilowatt solar system, and then there's a solar array that serves the entire community. Tied to that is a power secure 250 kilowatt, 255 kilowatt hour battery system, and there's no generator here. This community should maintain power in the event of a loss based on the battery, and B, doesn't require a generator to maintain that power. The homes are all highly efficient Energy Star with Energy Star appliances, and they also have connected devices that minimize the demand during an event, say a microgrid islanding event, or to help us reduce our peak loading during peak demand periods. And this is also out on the coast at Brunswick EMC. Our most recent microgrid is Eagle Chase. It's another community-based microgrid, except instead of being a sustainable community, this is a resilient neighborhood. So where battery storage can help us in the sustainability sense, it can also help us strictly from a resilient sense. This neighborhood has a 36-hour backup on the battery alone, but it also has a generator. So similar concept, but a different application in the sense of this, instead of really pushing for sustainability, there's no solar at this microgrid. They're really pushing for resiliency. So in the event of a loss of their distribution power, this microgrid can switch to islanding mode, and the battery initially supports, and then the generator picks up as necessary. So I mentioned we had microgrids, but we also have solar plus storage. I'm just going to highlight one of our solar plus storage projects, another commercial project, and it's with Roseacre Farms. This is a poultry facility. So another member consumer-owned asset location. It's a commercial operation, and the idea of the project, the solar plus storage project, is to meet their corporate sustainability goals. So we partnered with the cooperative and Roseacre Farms for this, and it's a two-phase project where it's phase one is solar plus storage, and then in phase two, we're going to bring in the generation on site, and we're going to turn it into a microgrid. Very similar to the other microgrids I just mentioned, but one thing I did want to highlight here is this is the first site where we implemented our hazard mitigation analysis process. There is a lot of danger associated with batteries, and one thing we did here is we brought an outside contractor to do a hazard mitigation analysis for the site and highlight what hazards were there, mitigation opportunities that we had for those, so that we could decide how to implement those. And we have since then taken that forward with all of our future projects. And then our substation battery energy storage. So we have 10 sites. They're co-located with cooperative substations, which provides lots of benefits because we didn't have to do as much siting, leasing, or interconnection issues because, well, we already own the land and we're at our cooperative substation. Although North Carolina Electric Cooperatives owns the battery, it's for the benefit of both the cooperative and the grander cooperative, North Carolina Electric Cooperatives. We've partnered with FlexGen. It's a North Carolina business. So it's 40 megawatts total across the 10 sites, 80 megawatt hours. We took into account both the physical footprint that these would take up at the sites, as well as the capacity of the substation itself. One notable aspect of these sites is they're all black start capable. So we built in the flexibility for the site to act as a microgrid in the need. They are not being implemented initially as microgrids. However, we have several cooperatives that have use cases for that, where either the transmission lines are not as reliable as they want them, or they have some downstream high valued customer that they would like to provide power in the event of an outage. And this goes back to what I was talking about, say first responders, command and control locations, or possibly shelters. So just a couple of things to think about when you're thinking about battery energy storage, and it's actually three. From our standpoint, it's not enough just to have battery energy storage. We believe you've got to roll that up to an aggregation platform. So we're across the state. We are rolling all of these into our distributed energy resource management system, not just for the financial piece, but also for the reliability piece. Second thing, always keep in mind what your inverter and site capabilities, what you're looking for, what use cases you're hoping to provide. And the reason I mention that is what I was talking about with our substation located battery energy storage. We know that the use cases will exist for those to require black start capability. So in order to form that grid, the inverter in the site needs to have some hardware, some software in the plan. So we had that front loaded. So I'd say consider the use cases and make sure your sites can support them. And finally, think of additional assets. A battery is a wonderful, very capable resource, but a battery with some generation, whether that's renewable generation or diesel generation or propane generation or swine waste generation, is even more capable. And then also think of those connected devices to provide load reduction capability for whatever you're trying to provide. And then finally, and this is sort of a thought, a final thought, put it that way. We talk about utility scale battery energy storage. However, North Carolina Electric Cooperatives is looking at how can we take residential level storage and create a utility asset. So basically scale up 50, 100, 300, 500, 1,000 small batteries within homes to a utility scale resource. This is already being done out west, and it's already being done in Europe. But we are starting to look at this as a 2023 project. We see the penetration of this technology in our cooperatives, and we want to be able to utilize it. Remember our imperatives of visibility and coordination. One thing we must be able to do is see this on our system, because if we can't see it, it's hiding load. but we really want to be able to coordinate its use for mutual benefit across the cooperatives and to the member consumers. What that's going to require is what you see on the right side of the screen. We need to forecast it. We need to do some pilot programs, which we're lucky enough to have Advanced Energy and Duke performing just such a pilot program that we're helping fund and we're participating in to see how customers use their battery energy storage and how we as a utility can use it also. In addition, we need to create installer relationships. So we are working with those that are installing either the solar or the residential battery. We need to come up with better standards. We need to formalize the interconnection requirements. We need to figure out what the communication paths are going to be. And then we can start seeing what economic value and what reliability and grid services we can obtain from these systems. So this is just a final thought. I wanted to present that when we talk utility scale, yes, that is the 5 megawatt, 10 megawatt hour battery or the 50 megawatt, 100 megawatt hour battery, but it can also be the small residential battery scaled up through aggregation. And that's all I had for today. Turn it back to you, David.
Okay, thank you, Erik, and thank you, Jason, as well. Excellent presentations, really appreciate that. A few final thoughts before we wrap up and go to our questions. This is really just kind of summarizing what we've heard already. Obviously, battery storage is going to play a key role in our energy transition for peak shaving, demand reduction, integration with renewables to solve the intermittency issues. You've heard him mention project deferral, using these as integral part of microgrids and ancillary grid services. We heard all those use cases mentioned, and all that is going to be an important part of that going forward. Challenges and opportunities, you heard this mentioned already, but just increasing demand in a very challenging environment. We all know about the inflation and the supply chain issues that have suddenly come into play in our country. So we have the global supply chain disruptions, inflation, economic uncertainty. One thing that I don't know if it was mentioned or not, but just finding the right people, attracting and retaining talent in a very challenging, tight labor market as well. And the increased adoption of EVs, which is putting a lot of just additional strain on the supply chain, the raw materials like lithium, but the components as well. On the legislation and policy front, in North Carolina at least, we have House Bill 951. There's a lot of details to be worked out there. This really applies to the investor-owned regulated utilities, but has an impact on the cooperatives and public power utilities as well. But at least we have some guidance there. Past few years, there's been a lot of uncertainty about where we were headed in that, but at least there were some guidelines there, just details left to be worked out. And then at the federal level, just recently, as some of the Infrastructure and Jobs Act money and the infrastructure bill funding is starting to be released. There was $505 million to boost deployment of long duration storage. We didn't really talk a lot about that, but that's something you're going to see coming up very soon. And finally, there's this Department of Energy program called the Long Duration Storage Shot. They like to use the moonshot analogy a lot of times, really a stretch goal, but the goal of that being to targeting a energy storage cost of 5 cents a kilowatt hour, which is a stretch. That's 90% reduction from the 2020 level, and doing that by 2030. So that's a stretch goal. Obviously, there's a lot to be done there, but that's where we are on the legislation and policy front. And so to wrap up, again, thank you all for these presentations. What we have now is we have some questions. We like to take a few minutes. These questions either came in during the webinar or were submitted ahead of time when you registered, and thank you for all the questions that we've had. So a few questions we wanted to touch on first, and I'll pose this to Jason first, and then Erik, you can jump in. But one of the issues is coupling battery storage systems with solar has been somewhat of a point of contention historically, given the use cases, the land constraints, and all the other issues. Can you describe challenges associated with solar plus battery storage from a design and an operational standpoint?
Sure, David. Thanks for the question. So obviously, we've been doing AC coupled solar plus storage for a few years now, and that's the predominant technology that is out there. But at Duke, we've also started looking, and we have been implementing DC coupled solar plus storage at our research facility since 2018. And it's given us a tremendous amount of learnings about the differences in between the two. And as we mentioned, what's most prevalent in the industry is AC coupled solar. So therefore, your costs are probably still going to be a little bit more in line for your equipment costs and setup than DC coupled. But DC coupled is starting to come and really show where some of its advantages are. The two main advantages that DC coupling can give you is with clipped energy and with low voltage harvesting. So what those two things basically mean is with clipped energy, you have something called an inverter to load ratio, and generally your solar in this case is going to, and your inverter is going to be less than what your solar can output. So let's say you have 150 kW worth of solar, but your inverter can only do 100 kilowatts. Well, if you have that case, you may want to couple it on the DC side with a battery. So you can take that excess 50 kW at peak times, and that's generally clipped and just goes into waste energy, and store it in the battery to be used at a different time. So you can do energy peak shifting. That's the first example. The second one is when we talk about low voltage harvesting. So the inverters themselves actually take a certain voltage level to actually turn on in the mornings and then turn off in the afternoons. And that's usually built up by how much sun is on the panels. But in the mornings before the inverter has the voltage that it needs to turn on, it's still, a lot of those panels are still creating energy. And in the afternoon, after that voltage is going below the threshold, you still have a lot of panels that are creating energy. And so those shoulders are now being captured inside that that DC coupled system for a battery. And I'll stop with this. There's two less transformations in a DC coupled system than an AC coupled system, and that makes it more efficient. And so that's really where a lot of people are looking.
Okay, great. Erik, anything you wanted to add on that?
There's nothing to add to that. It was a great response, Jason.
Okay, great. Let's see, another question regarding communication technologies. What sort of technologies are you using to address potential overload issues that might be caused by battery storage? And I guess, Erik, we'll start with you on that.
Sure. So it's a good question. I think understanding the site communication architecture of a battery energy storage site is important. So all utility scale battery energy storage systems will have a battery management system on the battery itself. And so that's sort of your ground level safety and possibly energy management capabilities also. Typically one step up from that for our sites, you'll have a site controller. That's either because we have multiple assets or possibly multiple batteries at one site. And the site controller, if the battery management system isn't doing it, the site controller is where you set those hard limits. So one thing that we're always concerned with is the interconnection limit. So wherever we are putting one of our utility battery energy storage systems, there is some sort of limitation to what we can discharge. The battery might be more capable than that, but typically we size the interconnection agreement to the size of the system. So from a control standpoint, it's about setting up the right controls architecture. One level up from that would be our distributed energy resource management system. And so if, a condition could exist where for some reason our distributed energy resource management system requests more than the interconnection agreement or more than the site can handle, but that's where those layers of control, those lower layers, either the site controller or the battery management system itself will step in and provide those limits. So it's really a design issue and a controls issue around the site itself, and then how the external entities interact with it. This is just something that's built into all of our projects.
Okay, thank you. Jason, anything else on that?
No, that's a wonderful answer by Erik. We utilize the same type of architecture that Erik talked about.
Okay. So we had a few questions, and it kind of around the same topic. It really has to do with recycling and end of life batteries. What are we doing about it? First of all, as these batteries reach their end of life, what is the plan to either do some sort of recycling or additional use, get additional use out of them? And also regarding, and a kind of a related topic on used EV batteries, because kind of two questions, but really the same subject. Is there anything being looked at around harnessing used EV batteries as utility storage in the future, either as at utility scale or residential? And Jason, we can start with you.
So I can take the last part of that question for
Sure.
sure. From my previous role as leading our emerging technology office, I can tell you that there is a tremendous amount of work looking at repurposing EV batteries for stationary storage. When we talk about an EV battery, it has different criterias for charge and discharge than what a stationary storage would have. It has different limits on how low you can discharge the battery. And so when EV batteries are said to be at end of life, they actually have a tremendous amount of value still left in them. And so truly what is needing at this point are these bright entrepreneurs that can go out and look at how to make a business case out of packaging these I don't want to say recycled, but these energy storage batteries out of EVs and repackaging them into stationary storage. We've dealt with many companies that are on that journey to get us where we need to go. And I do believe we'll get there at some point. The issue is always is scalability. And so we're going to have the batteries, but what is the correct process for those batteries to go from an EV, do a great quality control on them to ensure that there's no issues with them, then get them inside a package that can be deployed in stationary storage. So we are continuing to work with industry organizations like EPRI and even really new startups that come out of the DOE like ARPA-E, where we can get the newest technologies and really working with universities and national labs to put an emphasis on the reuse and repurposing of these EV storage units.
You're muted, David.
Sorry. One quick last question. So, what do you think the biggest challenge or opportunity is facing the clean energy transition at this point? And Erik, we'll start with you just real quick, and then Jason, and then we'll wrap up.
I think the previous question leads into what the challenges are. And Jason talked about the supply chain logistics issues. And if you link that to the recycle chain and you start thinking about what opportunities exist for the recycle side, because that's just going to feed back into the supply side. And I think that's the big picture behind the clean energy transition, is how do we take advantage of what we already have? How do we take advantage of renewable resources? And then how do we take advantage of what we've already built that we can repurpose or recycle and reuse? I think those are the big questions, but that splinters off into where do we get the resources? How do we manage those resources when they get into the supply chain? How do we maximize the utilization of that resource? And I think when that splinters out, it comes back to what Jason said also, it's all about opportunities that exist for entrepreneurs. So I think our, roundabout way to answer the question, the biggest challenge is getting those entrepreneurs into the system, getting them in conversations with people like Jason and myself and you guys at Advanced Energy so that we can take their ideas and build them into application. We need more is what it comes down to, but it's more people, more ideas.
Yeah. Okay. Well said, Erik. I think that is a really good way to answer that question, as well as that there is no silver bullet. We're going to need everything to get us to our clean energy transition. We're going to need the people, we're going to need the technology, we're going to need the costs to come down. And more than anything, we're going to need to ensure that we can do this safely and reliably. Because what we can't take any chances with is safety or reliability for our customers. And so I think understanding those and the fact that the standards around some of this stuff are evolving, and we're going to need to understand how the standards are going to impact the execution of a lot of these projects. So it's just more of a keeping up with how fast this industry is moving, I think, is going to be key for us.
Okay, well said, both of you. Thank you very much for that. And that's really all the time we have. I do appreciate that. Before we close, though, I want to extend our appreciation to all our stakeholders, the many people from Duke Energy, North Carolina's electric cooperatives, North Carolina Department of Environmental Quality, the public staff of the Utilities Commission, and Dominion Energy, who provide input and guidance to make this program a success, and especially our guest speakers today, Jason and Erik. I want to remind everybody to visit the NC Clean Energy Transition website at ncenergytransition.org, where you'll find recordings of all of our past Smart Grid series webinars, and a recording of this one will be posted there in a few days. At this point, I'm going to end today's webinar by sharing our participation satisfaction survey. You should see a link to the survey pop up in the Q&A session. It'll also be included in the email we send with a link to the recording. So please help us improve by filling out the survey so we can continue to offer valuable information and resources for you. So we're grateful that you took time out of your day to join us for this webinar. Have a great rest of your day, and we hope to see you again at a future webinar. Thank you.